So a natural question that arises when we're trying to find volumes is, what happens if we rotate around a line that's not the x or y axis? In this particular situation, we have a function g and a function f, and the area between this is being rotated around the line y is equal to negative c to form a volume. What we need to consider, f of x is the function that's farthest away from the line. It will be called the outer radius. G of x is the function that's closest to the line y is equal to negative c. It's called the inner radius. Always, we want to do outer radius first in our integrals and inner radius second. Now, the one way that you want to consider this is the line y is equal to negative c is like a shift of the axis down c units. And so inside of our integrals, rather than just integrating f of x squared and g of x squared, we're going to integrate f of x plus the shift, plus f of x plus c squared. The shift will allow us to account for this extra volume in here. Another way of looking at it is f of x minus the line will form our difference between the two functions that forms the actual radius here, f of x minus negative c. So again, we do outer minus line, inner minus line, so we get f of x plus c squared, g of x plus c squared. We will integrate both of those from a to b and multiply by pi. This is the case if we have the line below the two functions. If the line is above the two functions, then we have a slightly different scenario. Notice that y is equal to c is above the two functions f and g, and we're rotating around y is equal to c, so we're rotating up. In this case, g of x is the outer radius because it is farthest away from the line y is equal to c. F of x is the inner radius. It is closest to y is equal to c. Another thing that we want to do for proper notation is write the highest function first inside of our integral. And again, as always, the outer radius comes first in terms of which integral comes first. So here we've got c minus g of x, the difference between the two functions, top function coming first, and g of x coming first among the integrals because it's the outer radius. Then we do c minus f of x squared, squaring both of these, integrating from a to b, and multiplying by pi. And this forms our volume, rotating around a line that's higher than the two functions. If our line falls to the left of two functions that we're integrating with respect to y, then we need to be especially careful. In this case, f of y is the farthest right function, and g of y is the farthest left function. Our outer radius will be f of y because that function is farthest away from the line. G of y is the inner radius. So the question is, which comes first, the function or the line? In this case, the functions will come first because they're farther along on the x-axis. That'll be our instance of being higher than the other function. So in this case, f of y minus negative m squared, or f of y plus m squared, will be what the volume that's formed from the outer radius, the solid part of the shape. We integrate from d to c, because d is our lower limit and c is our upper limit. D is lower, and we're stacking our Riemann sums, and disks going up. G of y plus m squared will form the second part, the actual volume that we're taking out. Remember to multiply by pi. And our final case is, what happens if the line is to the right of the two functions? In this case, x is equal to m is our vertical line that we're rotating around. F of y is our outer radius because it's farthest away from that line. G of y is the inner radius because it's closest to the line. The line is on top because it's farther along the x-axis, so we get m minus f of y, outer radius, squared. We're going to integrate from c to d times pi, and then we do pi times the integral from c to d of m minus g of y squared, g of y being the inner radius. That's the volume we're taking out. All of these situations require you to draw a picture first and try to understand the situation. Sometimes you need to integrate with respect to y, sometimes you need to integrate with respect to x. It all depends on whether you have a vertical line, in which case you would do y, or if you're rotating around a horizontal line, in which case you would do x.